So for those who don't know, I'm Scott Cambrin. I'm the senior biologist and adaptive management coordinator for the Clark County Desert Conservation Program. I've been tasked with giving the overview of adaptive management from kind of the agency perspective, so to speak, even though I'm not an agency employee, so that's always great. But this is kind of based on these two classes that are available through the U.S. Fish and Wildlife Service National Conservation Training Center class. So basically everything is stolen from these two classes, adaptive management for structured decision making for recurrent decisions, and an overview of structured decision making. So first, basically, what is adaptive management? It's problem decomposition, breaking it down into components, complete analysis, and then recompose the decision. It's a form of structured decision making, and it's learning through management, adjusting management action based on what we've learned. So it should be focused on reducing uncertainty and influencing management actions. So these are just flow charts of what structured decision making looks like and what adaptive management looks like. And you can see that the first six on both of these are exactly the same. So adaptive management is just a more advanced form of structured decision making when you have uncertainty involved. So as far as those steps go, the first step is obviously problem framing. Problems should be framed as decisions to be made instead of saying we face competing interests between public and conservation goals for managing this property. It's better to say, how do we optimize the management of this property given multiple and competing objectives? So you're trying to be explicit and address all constraints and assumptions. Step two is to elicit objectives. You want to have a fundamental objective, which is your main overarching objective. It's the reason for caring about the decision. It's something you control, so it's not something that has to be done at Congress level or higher than you, basically. It needs to be essential. It's basically what happens when you keep asking the question, why is this important? Until you get to an answer of because or because it's the law, things like that. It's the top level objective. And then on top of that, it's a lot of times you'll have means objectives, which more influence the achievement of the fundamental objectives, and they're not always necessarily essential. Those are more like the how questions. How can I address these concerns? How can I measure success? Things like that. So step three is developing alternatives. Develop multiple actions based on fundamental objectives and determine approach timing, the appropriate timing for each action. What are the possible options to solve this problem? That's basically what we're trying to figure out on this step. Step four is the predicting consequences. It's the modeling step, basically. It's, you need to understand the consequences of the different actions in terms of those objectives. And models link those alternatives to the outcomes. And the models don't always have to be like these very complex, mathematical or GIS models. You can do very simple things, cost benefit analysis, decision trees, things of that nature, just to try to get to a point where you can make adjustments based on what you learn later on. And then step five is identifying your preferred alternative. It's kind of the trade-off step where you're trying to narrow things down. So this is the same model, one of the models from before. This is for building a dam or repairing a dam. You can see the rebuild option is never the best option in any case. When you remove that option, water retention is the same, so you can remove that option. Silt runoff has a monetary cost, so that can be rolled into the cost of the project. And so we end up putting down into a much smaller version of things to make our decisions off of. And so then once we decide which one we think is the best, we go to step six, which is just to implement the action. So that's how you get through structured decision making. And then on top of that, we have adaptive management, which starts the next step. But before we get to that, just a little bit about it. So adaptive management is structured decision making with recurrent decisions under uncertainty. So, it's something that's coming up multiple times and we have a level of uncertainty. Something about it we don't understand. There's four main types of uncertainty. There's your environmental variables, climate, which is the one we probably, that's confounding our projects the most right now. Partial observability, which is your observer error and your sampling variability. Partial controllability, which has to do with like regulations and their influence on outcomes. And then structural uncertainty, which is the lack of understanding of the physical process of the resource. And this is the one we're trying to do our best to figure out with, with the management actions. So the management actions are dealing with these physical processes of the resource that we're trying to determine. There's two main types of adaptive management. There's a passive adaptive management, which focuses more on the resource response, targets the efforts of the management on resource conditions and not so much on learning. And then there's active adaptive management, which is more, the decisions are more focused on learning. The target effect of the management of the resource is not, of learning is not resource conditions. You may end up in these cases with not the best overall end to your management action, because you'll, may have areas that you've set up that don't do as well as others. So in like a seeding experiment, you may use a couple different types of seeds and one does worse, but now you've learned that one does worse. Whereas before, if you're just putting out all of one type of seed, it may do one or the other, and you won't know if something else that would have done better or not. After that, you're looking at monitoring, which is obviously essential to determine if things work the way you expected them to. And this should be based on the overall project objectives, and you need to consider scale and effort. Step 8 is updating the predictive models. So learning and adaptive management is the reduction of the structural uncertainty, like I said before. And the easiest way to go about figuring that out is to use the results to update those models so that we have a better understanding afterwards of what actually came out of each project. Hopefully moving towards a point where we actually fully understand the system. And then last is just reevaluating the trade-offs. So you're basically going through all that again. You've now got new information. Hopefully you've looked for new information that's out there available from other people, and you can incorporate that into your model and maybe make a different decision this time. Or maybe you need to make the same decision and change the variable inputs. But it's just a way to kind of reset up the next step of the experiment, basically. And that's all I got. That's 2 weeks of class rolled into 7 minutes.
Wow, very impressive. So yeah, there are a lot of complex and abstract concepts that Scott just introduced. Obviously, everybody has their own concepts and way of framing adaptive management, but does anybody have questions about what Scott just introduced or needs for clarification before we start discussing it more on the panel? Okay, great job, Scott. All right, Scott Abella is going to moderate this panel. Are you ready, Scott?
I am. So just like yesterday, we have a series of questions posing to our panelists, which is Scott Cambrin, who you just heard from, JJ Smith from Las Vegas Bureau of Land Management, Neil Darby from Mojave National Preserve, Kurt Duzer from NPS, and then John Klum, also from Bureau of Land Management. And so the first question, we have three questions that we wanted to focus on, but certainly if there's other points that are raised, we can go in different directions. The first question that we wanted to pose to our panel is, what monitoring is your agency or organization currently doing? And do you have any examples where this type of adaptive management approach of doing management actions followed by monitoring has informed or even altered the types of management activities that you're doing?
Sorry, I missed half of that. Are you talking to me or did you pick someone else?
This can be to anyone.
Oh, okay. Well, I guess I started talking, so I'll start. So we monitor at our restoration sites and any kind of restoration done on the easements, either by us or by other entities such as power companies that put lines through and things like that. As Stephanie talked yesterday about the monitoring we do on the road reclamation projects, we're also monitoring desert tortoise occupancy on the BCCE. and try to incorporate that into the decision-making process when appropriate. But Stephanie will talk a little bit more about that during her talk a little bit later. It's informed management by showing areas that are not performing in ways that we'd like, specifically with the end caps. We've had many instances of people eventually driving through the vertical mulch after a couple of years. So we've recently switched to trying to use live plants and added species such as yucca to hopefully curtail some of the behavior in the future, some of that behavior in the future, but that's still a work in progress. We're still continuing to monitor and see how that turns out.
Yeah, this is John Klum. Here in Utah, within the Red Cliffs and Beaver Dam Wash NCAs, a lot of our adaptive management is related to the ever increasing wildfires. Our habitat rehabilitation projects are in 2016 to address the large fires that occurred in both NCAs during the summers of 2005 and 2006. And in 2020, there was a complex of 4 human-caused fires in the Red Cliffs NCA that burned approximately 12,000 acres, and the majority of both the 2005 and 6 and 2020 fires were within desert tortoise habitat. So annually, we start off in 2016 of 7 species of plants, had a grid system with 100 acres, planted approximately 5,000 plants. And we just wanted to see what planting methods, if topography influenced, what species worked. And we took that knowledge and we realized, okay, well, ephedra, white bursage, brittlebush, and creosote survived well there. And we also learned that the plants that were planted within washes and the sides of washes did well. So then we moved to the Red Cliffs at another site in 2018, and we took what we learned from that study and we planted plants in a burn area, but we also tested slopes in the base of Rocky Hills. And then we looked at what plants survived. And so now we've gotten to the point where we have a high survivorship and a reduced need for supplemental watering. And we've had really good success, but it's very reactionary. And just quickly, a couple other things that we've learned is that at the beginning in 2016, it was like, okay, let's go out for 5 years and figure out survivorship. These plants are caged, each one with chicken wire cages. So they're unavailable for the tortoises who are in need in those fire damaged habitats. And so one thing that we learned was that data from the 2016 restoration project showed a 4.5% decrease in survivorship from year 1 to 4.25 years. So that means that plants that survived 1 year had a good chance of surviving greater than 4 years. And that's something that was shown in other planting projects. If you can get these plants to survive to 1 year, they have a good chance of making it and meeting the goals of flowering and reproducing. So this ties into monitoring, that we do not, with a small staff, have the budget and people to go out, especially if you're planting thousands of plants annually. So currently our goal is to plant plants in burned areas, in areas where there's need for tortoises, and then monitor them for 1 year. And then we just report that success.
Yeah, those are excellent points, John.
So Scott isn't the other BLM guy. I guess I could go next. I think, John's working up there in an NCA, National Conservation Area. What we do in Las Vegas, we have Red Rock National Conservation Area as well as Gold Butte National Monument, but then we also have some other multiple use BLM land. So, we have some monitoring that's specific to each of those. But in general, we really do 2 types of monitoring. One is project specific, and it's related to some public land project, and really proponents are responsible for monitoring these various aspects of their project so that they attain a certain success standard that was agreed upon. So those types of projects like transmission lines or other rights of way projects, those sorts of things. That's really one set of monitoring, and it it's often, effective. Sometimes it's not as effective as some other types of monitoring for informing, future actions so that we can learn things, but that is one of the types of monitoring that occurs. And then we have things that are more, BLM originated or larger projects that we've received funding to do, like big restoration projects like John is doing up in Utah. And for these, we learn an awful lot by incorporating or integrating with partners. For example, Dr. DeFalco working on our burned area restoration project. There's no way we could have done the monitoring for that and adaptive management based on that without just an extremely robust sample design so that we can learn something regardless of our success initially. So I mean, those are two types of monitoring. And then we have some programmatic type monitoring. For example, Dr. Eskew mentioned AIM, assessment, inventory, and monitoring strategy yesterday. This is a BLM wide effort. I think there's something like 26,000 plots now established nationwide, and a bunch of those in Nevada, which is an early participant in that program. So these are coming online as a resource. Some of them have already been remeasured. They're permanent plots, so that's going to be helpful for assessing conditions over time. But as a lot of people have pointed out, we still have work to do in identifying, quantifying habitat characteristics and measurable indicators, those sorts of things, and then lining those up with what the AIM protocol actually, gathered under that protocol, and making sure that we have enough of those things in common that we can use AIM data, excuse me, to effectively characterize habitat. We also have a fuel monitoring program and weeds monitoring programs. And those are, small programs. We have usually one permanent person for each of those, and, occasionally other folks to help out. And so over, 3 million acres, it's not something that's very comprehensive, and we tend to focus on specific areas. And as Kurt Deucer pointed out earlier too, the early detection and rapid response is a critical component there. And that's something that I think we really need help with to be able to implement on a district-wide basis. We just don't have a big group of people that we can turn to and right as things are greening up to get out and canvass the district. And then one final thing in my notes here, the Emergency Stabilization and Rehabilitation Program. That's another program we have that monitors for BLM, specifically in burned areas. So that's another one that just spins up when there's a fire and a team is assembled to deal with it, but does produce important information on things like weeds and fuels.
JJ, that's a great overview. Thank you. This is exactly what we want for, kind of giving an impression for what you all are doing to compare with what other people are doing and other ideas. That's really, really good overview. Any other panelists would like to answer this question? Kurt or Neil?
Okay, yeah, I'm here at Mojave National Preserve. We're like most all other agencies. We have not a lot of staff and funds to monitor everything we would like to, but we mostly focus on invasive species. I think that's been one of our bright spots where we know we do the targeted monitoring. Checking to see if the plants are coming back, mostly salt cedar, Sahara mustard. And then we've been able to adapt our treatments or management based on what we're finding. We've successfully eradicated several stands of salt cedar. I still get those little stems that like to come out no matter what, but they're so small and few now that we can stay right on top of it. We did some extensive biosphere restoration work out here, and these are focal disturbance sites like a livestock corral or water source that livestock gather around. We tried a bunch of different methods of trying to break the decompaction, reseeding, bringing in perennials more favorable to tortoises, controlling the invasive species, schismus, puncture vine, things like that. You know, that we had highly variable results between all of them. We can say elevation had a big effect. The amount of water we could irrigate with had a big effect, and herbivory, of course, was an issue. Even tortoises came into these sites and kept nibbling down on our seedlings. So we've been able to take everything we learned from these different sites and and we keep ongoing with biosphere restoration. But the key has been monitoring. Then, of course, we have the post-fire. Last year, we had some major fires in the preserve, Joshua Tree Forest, invasive species monitoring, Joshua Tree recovery monitoring. We've been undertaking some management actions to help bring back some of the Joshua trees, make sure the native species come back, keep the red brome under control. The one thing we found from the dome fire was that the SEMA dome was actually in very good condition. It had an incredible diversity of native bunch grasses, native annual grasses, shrubs. And so it's going to be very interesting to see if the fact that it was all there to begin with, how well it will come back. And then, of course, our biggest monitoring involves the right-of-ways and grazing permits. We try to keep the disturbance to minimal, keep the native vegetation intact as much as possible. So we monitor these activities so that we don't have to go in and do major restoration work.
Excellent. Thank you, Neil. That's a high diversity of activities. Kurt, would you like to chime in?
Yeah, I'll try and be as brief as possible here. We can move on maybe to the next question, but the Park Service in general has a large national program of inventory and monitoring program, and there's a network of that throughout the country that represents multiple parks, and that's more for it's more long-term monitoring program for long-term decision making. It's not really applied to kind of the short-term decision making that I think we're really addressing with adaptive management in this workshop here. But so what, and generally, like with invasive plant management, what we do is if we're addressing a species that the methodology is not refined or developed yet, we'll partner with researchers and do traditional replicated studies evaluating various treatment methods, and then once we learn from that, then we take it and apply it on a more widespread basis and implement that. And then I think the critical thing with at least invasive plant management is that we map everything, spatially map all treatments and provide lots of metadata and information about each treatment, and then we share the data. And many times we have long-term partnerships or projects where our actual team members will go back, the next year in the same area and do observational monitoring and retreatment as needed. But again, we share the data for partners to do that as well internally within their staff, and they can determine whether we've met the objectives. And then it's also available for researchers like Scott Abella here. He's tapped into the Park Service's National Invasive Plant Database and evaluated on a large scale across the country the effectiveness of invasive plant control by just using the spatial data. So it's available through long-term determining whether effectiveness through the long term. I think some of the things with revegetation that we found, and certainly with annual invasive species such as bromes and Sahara mustards, and I caution everyone that you will get a different response depending on what year you apply it. I think it's post-weather, after treatments, whether it's re-veg or invasive plant control. It's really a lot of the post weather is the real driving factor. And of course, that's introduces all kinds of variability and unpredictability. But in perennial species, it's more consistent. I think we can be pretty successful, by the monitoring. But again, with annual seed bank species, you can be lulled to think you're successful, but it's mainly due to the weather, the lack of germination events for such as Sahara mustard and all. But I think it's important there where you keep applying it on the landscape, even when there's low production for these annuals, because the whole idea or target is managing the seed bank. And eventually the seed bank will get depleted through time with a combination of either the weather is not favorable plus your management actions. And so that can just be something to be aware of. And that's what I got in closing there.
Thank you, Kurt. That's great. And there's a little bit of overlap with the next question with some of the responses for the first question. Just maybe a couple follow-up points in that the adaptive management process really is kind of an overall concept that then can be addressed and fed into with as Kurt mentioned and others mentioned, in sort of institutional monitoring, both at the local level and then also tying into some of the national efforts, such as the inventory and monitoring program of the Park Service and the AIM program of BLM, and also the fire effects BEAR program and so forth. Forest Service would have different monitoring programs as well. And then can also be, sort of, at a local level, customized for some of the factors that Kurt was just mentioning. Just trying to find out what works in different years, both in terms of monitoring an existing project and then maybe adjusting some of the actions that are maybe being revealed would be good directions to go as a given project is progressing. To sort of make those adjustments, and then also to inform future projects as well. And so that ties into a little bit here with the second question, which again, there's a little bit of overlap, but maybe honing in a little bit here with desert tortoise specifically, and just asking the question of, does your agency or organization apply adaptive management programs specifically for desert tortoise habitat restoration, such as, for example, taking any of the Fish and Wildlife Service population data or observations within the park of tortoises or within different protected areas, and then any examples of using that type of information then and applying that specifically for desert tortoises, and including with collaborations with tortoise biologists as well. So kind of an open-ended question on that.
Scott, this is John Klum. I'd like to provide some input on that, but first on my comments from the last discussion at the top, it stated that BLM does not have the capacity right there to plant. We are planting thousands of plants annually. And so I would just say BLM is planting thousands of plants annually, semicolon, and they are planting where there is a need for tortoises. We're monitoring for 1 year, and then we're recording and implementing the lessons learned. We're implementing them, and that's what's increasing our survivorship. And but to address the current discussion, we have within these burned areas, when we go out, for example, the Cottonwood Trail Fire, myself and my biological interns went out and did, it was about 1,000-acre fire, and we went out, there was about 900 acres on public land, and we went out and did 10-meter belt transect surveys over 618 acres of it, which was a tremendous effort. And then we document the direct impacts of the fire. So we looked for live tortoises, dead tortoises. We also document the location of deep winter burrows and shallow summer burrows. And then we take that biological data of where the tortoises are at and the habitat that they're using. Then we look at where there's friable soils, where there's topographic features that will benefit survivorship, such as slopes, the washes, the base of rocky hills. And that's where we focus our planting efforts. So it's not just looking out across the landscape and go, oh, there's a big wash, let's plant. We definitely tie in actual on the ground current occupancy and use of the landscape by tortoises into the equation.
Okay, well, this is JJ. I'll jump in. I guess on that one. We do have these institutional adaptive management processes. Even in the NEPA planning process, there's opportunity for each project we do to learn on past projects and current research to plan things a little differently or select different alternatives. For specific projects like John, we do some of that very specific monitoring, and I definitely feel like collectively we're all learning more as we've attempted to scale up projects across the landscape, or these bigger projects. I feel like, and this maybe applies more to the next question, is that we haven't really institutionalized some of the landscape scale monitoring, things like looking at or developing remote sensing based tools at different scales, to be able to monitor. Like, every day I think of how drones could be used better, more effectively than sort of the hit or miss monitoring that we're able to do right now, or just better, satellite remote sensing tools that we can use off the shelf, or modeling tools, those sorts of things that we can use year to year, or even on finer scales than that. So that's probably part of the next question, but I feel like that's where we have a hard time applying, information right now in a timely manner, these sort of real-time decisions. Oh, let me add one other thing I forgot to mention is, I feel like we have been adapting pretty well to new information and designing some monitoring around that, and not just for habitat characteristics, so or the sort of the more vegetation soil characteristics that we've been talking about, but also things like, working with Fish and Wildlife Service to monitor culverts for tortoise and other wildlife use of culverts, and whether or not that is connecting habitat, monitoring power lines to for red nests, those sorts of things are a big push in our wildlife, with our wildlife biologist, Evan Myers, and others. And those have been very responsive, I think, to emerging issues and more information as various groups are looking at, like Flo's transportation ecology group and others are looking at these issues. But again, from a comprehensive standpoint, we still don't know exactly where on the landscape are the best places to make decisions based on this information.
Thanks, JJ. Would any of our other panelists like to add on to question 2, or are ready to move on to the next question?
Yeah, sure. I can give you a pretty brief overview, I guess, of what we've done. When I first started at the county, it was very, I'd say, informal adaptive management. We've started to move more towards the formal process with like the K2 or K2 route restoration and using different methods, different seeding methods to try to see if there's any different results than what we get. We've also, like I said, Steph will talk to this a bit more in the presentation later, but we've used our desert tortoise occupancy data to kind of decide on where we should focus our restoration efforts on the easement. So we've done some of that and linking those two things together.
Thank you, Scott. And so for our third question, related to dealing with uncertainty and risk in applying habitat management activities. And just a couple of examples of that we talked about yesterday. The one example was using a bet hedging approach to deal with the circumstances now that we're having more years now, it seemed like, that are warmer and drier, that are just not necessarily as amenable to restoration. So we talked about using a bet hedging approach and applying multiple treatment types. So in the example we gave yesterday, it was using an abiotic restoration treatment, the vertical mulch, which worked really well in a year that was very low rainfall and all the outplants ended up dying. Some other examples of that could be using a wide variety of different species. A couple people have mentioned that in terms of the species selection, and relating to Judy's talk yesterday, that's also a bet hedging approach. There are costs to that, of course, because then more plants have to be dealt with for plant materials development, but then there might be a greater chance that some of them will perform well during climate any particular year. And of course, too, we are starting to get a little bit better at being able to predict beforehand what some of the years might be climatically, but we're probably not at the point yet of being able to be 1 or 2 years out, particularly for the site-specific information that managers really need to be able to do things like plan gearing up for seed collection and so forth for example, a good year that's forecasted 2 years in the future. That's really difficult to deal with. But just as as a prelude, then, just with those examples, just curious if any of the panelists have examples to share for creative ways in which you or your organizations have dealt with this uncertain environment and tried to minimize risk when applying desert tortoise habitat management actions.
Hey, Scott, this is Neil. I guess I could kind of start on with that. We're kind of limited in how we can address some of our issues. So I'm going to use our biosphere restoration work. It gets incredibly expensive for such a small area. At least we can concentrate on that small area and put much more effort into it. And so how we've been kind of applying it is where we get into a midst of a drought. I tend to go out through more like contracts. I go out through contracts or agreements with the USGS or CESU, cooperative ecosystem study units, and then we can put that money aside, and it can be spent out over 5 years. And so it gives us the ability to if we're in an exceptional drought, we can just say, hey, let's just wait, and we pull off. So that's kind of a way we can approach it. I also, we've also tried to bring in outside group. We have the USGS now involved with biosphere restoration work and recovery and monitoring. We were able to get that through a USGS proposal. I think that's been our biggest way to address our uncertainty is to reach out to these other agencies and universities and groups to come out and give us a hand. And it's not 100%, but we've had some success.
Neil, thank you. That's a really good point. Thank you for bringing up the financial aspects of it, because that can certainly be part of the adaptive management process, because on both ends, for myself, both in terms of having funding available for projects and then being on the end of receiving funding for projects. Probably we've all dealt with that situation where there's a great study plan or great management plan and we have funding for it, but then it's just not appropriate to take that management action or implement an aspect of that research in a particular year. And as you mentioned, it's really nice for the cooperative agreements now to have it be a 5-year period. And I think the federal government has been oscillating between 3 and 5 years for the maximum agreement periods. And so it's wonderful to have it be a 5-year period, just to enable that flexibility, just like you said, to whether it's a seed collection effort that an agency's funding or research or your own staff, to have that flexibility is huge. As well as perhaps diversity of funding sources too that can be spent at different times, rather than just tied to the federal budgets. So I really appreciate you brought that up. I mean, we really could have an entire session just on some of the funding aspects of this, I'm sure. Would any of our other panelists like to weigh in on some examples? We still have time, and we can even ask some audience.
I have a couple things real quick, hopefully. I just want to say first off on the bet hedging thing, I feel like that's a very pretty close to formal adaptive management, because if you don't do that, if you just pick one way to go, you'll get a success rate, but you have nothing to compare that to. But when you use a bet hedging strategy, use multiple types of things, you can actually compare how those work against each other. So you're learning a lot quicker in that way, which is what formal adaptive management is all about. I think I don't have specific creative ways, I think, to address this, but I think the best way that I think of doing it is looking at new technology, something that JJ alluded to earlier, trying to, we do a lot, right now with tortoises, trying to figure out how to get do a lot of surveys with drones is something I'm, working on, but looking for technology in other sectors that we could then incorporate into our sector to help make our things a lot easier. And I think the same way that is also what techniques are people using in other environments, forest, riparian, that we may be able to adapt to work in a desert environment.
Yeah, I think some experience with bet hedging and the uncertainties that we have in our desert environment and how plants respond and annuals particularly is one example is, so pre-emergent treatments on, let's say, red brome or a Sahara mustard generally would occur in the fall, before emergence. So we're betting that and that costs money and effort and planning, and you're applying a chemical out there on the landscape, no matter what scale you're talking about, small or large, and it may be for naught. red brome or cheatgrass and certainly Sahara mustard may not germinate that year. So in a way that was all, yeah, could be construed as wasted effort, wasted money, and potentially adding, you know, chemicals that you didn't need to, right? So a lot of, we've kind of gone back and forth on the pendulum. You think, well, it's better than to wait for the emergence and then respond. And of course, you then need to be more effective, you need to add like a post-emergent, such as glyphosate. We've kind of come around, like, to me, it depends on what you're protecting. And so with things like structures, visitor centers, houses, you know, headquarters of these facilities or whatever in the forest environments and desert, it's probably worth doing the pre-emergent. And if it doesn't come, because once you put it out, you've wasted, you know, it's only good for 1 to 3 years. So you've just, it starts biodegrading immediately once you apply it. So the clock starts ticking. And so, like, I guess it depends what the value that you're trying to protect. So, you know, things like the Red Rock Visitor Center and some of the housing out at Calico Basin, I think the BLM and what we've partnered with them, they've decided, you know, that's an important area to do pre-emergent, probably regardless of whether production occurs. And then it's something that just needs to be maintained through monitoring and more maybe repeated. But maybe we need to look at tortoise habitat, like prioritize certain tortoise habitat that is just absolutely, you know, most critical to value, and consider a similar approach. You know, now that's with the annual grasses. With the mustards, I'm a proponent of more like responding to them. I think the variability of its germination seems to be more, or, you know, less frequent. And so I think with mustards, because they're not near as widespread, obviously, as the bromes are on the landscape yet anyway. So that might be, I feel like it's better to wait and respond in some of the selectivity, because they don't create quite as much cover across the landscape. So it kind of varies. And then I think it really goes down to, I like what JJ said earlier, and I think this is the untapped future in vegetation management, is using more satellite imagery, green up, being able to detect green up at earliest stages as possible. And then, you know, being able to management response to that is so important, and is the difficulty of it. But yeah, I think that's where it all lies. And if you take, you know, you take structures, for example, on your areas that you want to protect, well, you take tortoise habitat, get them spatially on the GIS layer, and just focus on the satellite imagery and green up of that area. So you're not trying to focus on 3 million acres or 10 million acres of green up, more like what's the concern that we have on a chunk that we can manage and bite off. But, all right, I'll close at that.
Thank you, Kurt.
So,
we can even solicit some questions here in the chat box from our audience if we'd like, but any of the other panelists have any other examples to highlight?
Scott, Judy Perkins put a question in the chat saying, Judy, you can ask your question.
Yeah, so just wondering about like Esplanade in particular for a pre-emergent, like every year application. Has there been work done on the effects of the native annual forbs with that treatment? I know it's pretty good at protecting the perennial species, but just wondering about the annuals.
Yeah, Bayer has done quite a bit of research on that, and it's surprising how, at least early results are, how selective it is at these annual grasses. I'm trying to think of the main researcher that did that work. He's out of Colorado State, but anyway, preliminarily, it does seem very selective. But others may have, input or their own reviews of that.
But, and then also kind of worrying about the native annual grasses like the Bouteloua barbata, Bouteloua aristoides, maybe some of the threons.
Yeah, so I mean, those points are well taken. I think it all comes down to, again, is why you're going to manage. You're presuming you're losing. Okay, so you're willing to take some maybe negative, accept some negative responses because we're to that point. We know that the annual invasive exotic bromes are fueling most of the wildfires in the Mojave Desert. And so breaking that link and certainly that cycle, and that's another reason not to apply these methodologies across massive landscapes. I think it's more important to be strategically in corridors and smaller acreage to protect the larger acreage, just because there could be unknown negative impacts to these, other annual grasses and all as well. So,
Thank you.
but they do have tolerance. They've developed a lot of research on what native annuals and I believe grasses are included in that of tolerance to indaziflam.
That's a
Can I
very
chime in
good-
there on that one as well? Oh, sorry.
No, go ahead. Thank
We've
you.
just been doing some work with that at Utah State University. And one of the problems in determining what impacts it has on native annual vegetation is usually the plots where we're looking, where there are invasive grasses, where there is Sahara mustard, those annuals have already been displaced. But we are seeing, of course, there needs to be more work on this, but some of those annuals or short-lived perennials, including desert marigolds and some others, and also it's not a native, of course, but fillery, it doesn't have an impact on those because Esplanade has activity just on that top crust and the top level of the soil. Seeds that are able to germinate deeper in have potential to not be impacted by that particular herbicide. But this is just preliminary observation.
Thank you for that. Any other quick questions until we turn it back over to Julia and Colleen?
Just one quick comment, if I could. So with the raven management that we're doing and some of the monitoring that we're even starting in Southern Nevada, we'll be tying a lot of this to what we're referring to as tortoise recruitment priority areas. And these are locations where we have a high tortoise observation rate to the number of transects that were walked in those areas. We're usually looking for about a 33% observation rate in those locations. And then we buffer them out based on some of the information we've collected relative to ravens. And so the more that we can layer these types of habitat restoration with predator abatement, I think the better outcomes we're going to have.
That's an excellent point. And it's just like you're saying, it's these multi-factor interacting stressors. That's such a big challenge. And going back to Roy's paper, there's a 2012 bioscience paper that Roy published. Defer to him to hand out the citation, but just discussing all of these interacting factors and trying to develop techniques to deal with them one at a time, but simultaneously, if that makes sense, using techniques just like you described. Perhaps if we have a choice between doing say a vegetation restoration action at two different sites and we're aiming it for the tortoise, maybe we would want to select the site that has less common raven predation, for example, where we might be able to get a better outcome for tortoises at that site, And we first then, if we're going to want to do that at the second site that has a lot of ravens, we would need to deal with the raven problem first before, you know, maybe applying the vegetation restoration. I really like that. And thank you very much for that point. And would really like to thank the whole panel here. Really appreciate your ideas and the questions here from the audience. And I think we're ready to turn it back to Julia and Colleen for a preview of this afternoon here before